Good morning, everyone. This is the first video of Module 1 Contents of Theory of Machines. In Theory of Machines, in the first module, we are going to discuss about what's a mechanism, what is a machine, and how we are going to transmit motion from one place to another place. What are the various constraints you are going to apply for the given structure, or it may be 2D element or 3D element. And further, we are going to discuss about inversions of kinematic links. So further, we'll be knowing about velocity and accelerations of slider mechanism and forward mechanism. So if there is a rub, rub where happens when the motion makes motions, that is also taken into consideration. So all these things discussed in detail. So different COs, what you are going to learn in this theory of machines is you are going to apply the knowledge of mechanism and their motions and the inversions of different mechanism. That is in the module 1. In the module 2, you are going to analyze the velocity acceleration of links and joints of the mechanism, solve problems on mechanisms of static and dynamic equilibrium, carry out the balancing of rotating masses and also reciprocating masses, investigate different types of governors used in real life situations, and the effect of gyroscopic couple on airplane, plane disc, and also are going to check how stability happens for a two-wheeler and the ship. So like this, you are going to learn in this theory of machine. So in the module 1, these are all the contents you are going to learn. You are going to learn about what is a mechanism and what's a machine, and you are going to differentiate between mechanism and machine. Further, you are going to know about kinematic pairs. In the kinematic pairs, you are going to know different type of pairs, and you are going to calculate degree of freedom for different structures. So whether it is balanced or not, that you are going to check out. Whether it is going to transmit motion with respect to the given constraint or not, you are going to see. So in the after kinematic pair, you are going to know about the kinematic chains and their classification. So kinematic inversions happens to the given chain. So after this introduction, you will be knowing about the velocity and acceleration of planar mechanisms. So you are going to solve the problem by graphical method. Velocity and acceleration of four-bar mechanisms, slider crank mechanisms, and mechanism illustrating Corioli's component of acceleration are going to learn. So angular velocity and acceleration of links and velocity of rubbing you are going to learn. So these are all the components you are going to learn in the first module. So under static force analysis, you are going to learn about free body. You are going to learn about the static equilibrium and the static forces acting on the two and three force members, and how we are going to analyze the force and torque for the different body. For that, you are going to analyze the free body diagrams, and also you are going to apply the principle of virtual work for the given mechanism. So static force analysis will be carried out for four-bar mechanism and also slider crank mechanism, considering the friction or without friction when it is applied at the workplace. So further we'll see what's the mechanism. So mechanism, it is nothing but the motion one caused constraint and predictable motion to that. So here in the mechanism, what we expect, suppose if we apply force at one end or utilize the energy at one end, it must be able to use at the other end. So by doing that, what we do is we are going to get the required output. So in the mechanism transmits and modifies the motion. So if we have a constrained or unconstrained at one end, you are going to get the output at the other end. So the two examples what is specifies for the mechanism is four-bar mechanism and the slider crank mechanism. So this is what here he gives an example. It is a piston and cylinder arrangement, or it's a four-bar chain mechanism, or it's a wind wiper. So like this, he gives different examples for a mechanism. So when you take a machine, So machine is a combination of mechanism where it is going to transform available available energy in one form to another form to do certain type of desirable useful work. So here if you see the lathe machine, in the lathe machine we can see that the various forces are acting at one point. So workpiece is fixed between the live and the dead center. So with the help of the stepped cone pulley, you are going to transmit the required energy from one place to that place. So like this, a machine, it is meant for useful work where mechanisms are combined to get the useful work. So further, if you take a structure it is you can see there is a there is a structure where it is mounted on the standard roof. Parallel cord is added in the at the needed place. So you can see a Howrah bridge where at the two ends the it is fixed and throughout the length the various these structures are added so that it is going to take the load. So this is a structure where we'll have a number of resistant body which is going to take up load. No relative motion between the members it is there. So when you take kinematic link, it is meant it is meant for transmitting the required force with negligible deformations. When you take different type of links as shown in the figure, there is binary link, ternary link, and quaternary link. So before going to the different type of links, uh, first we'll know what is a rigid link. Rigid link is one which does not undergo deformation. So if you apply any load, it doesn't fail. Example is connecting rod and the crankcase. So if it's a flexible means there will be a force partially deformation in the link. Example is belts, ropes and chain. Further, there is a fluid link. In the fluid link, what we can expect is the motion is transmitted through the fluid by pressure or compression only. The best example for this is jacks and brakes. So here also you can see binary links, ternary link and quaternary link are there. So based on the type of link what we see here, if it's a binary link means there are two vertices. If it's a ternary link, there are three vertices. If there are quaternary link, there are four vertices. So you can have connectivity to the different links based on the amount of links we can have. So here what all it is shown, here we can attach a different links so that the transmission happens. So in the binary joint, what we can is two links are connected at a joint. So there are two links at a joint as it is shown in the figure. There are two links connected by a joint. If it is ternary link, you can see there are three links connected at the joint. If it is quaternary link, there are four links connected by the joint. If I is the number of link connected at a joint, it is equivalent to I minus of one binary joints. So like this, it will be applying in the equation. So further, if we take kinematic pair, so in the kinematic pair, best example what it uses this the crank and slider linkage, what it is going to happen. So two links of a machine when in contact with each other set to form a pair. So when how to define a pair means there will be two link elements. So with a joint it is connected, then it will be having a pair. So if the relative motion between them is completely or successfully constrained, then it is known as a kinematic pair. So here, if there is a relative motion between them, or it is with the constraint what you are going to have, then we can expect the motion to happen in the particular direction. So here you can see in the crank and slider mechanism there is fixed pivot, and at the other end where you can see the other link, it can be able to slide in the horizontal direction. So this tells about the kinematic pair. So based on the kinematic pair according to the relative motion, if you take a sliding pair, in the sliding pair you can see that the in the given block, the rectangular bar in the rectangular hole, it is going to slide in the horizontal direction. So here in the 2D diagram, in the 3D diagram as well as the 3D model diagram, it is shown. Further, if you consider turning or the revolute pair, the collar shaft revolving in a circular hole, it forms a turning or revolving pair. So further, if you take the rolling pair, you can, the best example is you can take is about roller bearing, where there is an inner race and outer race. So between the inner and outer race, there will be rolling elements which will be held by the separator. So here it is also going to form a pair which will be having a rolling motion related to each other. Further, if you take the screw pair or helical pair, if the two mating links have a turning as well as a sliding motion between them, then it is called as a screw or helical pair. So here, if you take a bolt and nut, bolt it is fixed, which has got a threads on this structure. If you move the nut on the thread, it is going to move and it is going to advance throughout the length. So here we can expect a sliding motion uh, as well as advancement also had happened. So like this we can expect two type of motions to be present. So further, if you take spherical pair, in the spherical pair you can say best example is using a joystick, where we can expect the axis motion to be in different directions. So here the sphere turns inside the fixed link so that it is going to sense where it has to move. Further, if you take a planar pair, you can see a table which is going to move in the two axis direction, and also it is going to rotate the workpiece. So like this in a plane, you can expect the motion to be present.